Hey everybody, Mr. Takahashi here. Okay, period 1 and period 5. You guys were asking about some basic information on the periodic table as well as board diagrams, so these next couple of videos are hopefully going to address that. We're going to take a look first of all in this video, the periodic table, this thing here, and I want to quickly highlight the important bits of information that you should be able to pull from the periodic table, especially if we look at one of these squares here and take a look at a specific element. What do these numbers mean and what can they tell you? Okay, so what I'm going to do is I'm going to focus in on this particular element here, sodium, or you can see it's the Na. And I'm just going to move this periodic table out and bring this. So this is as though we've selected that box. This is that box on the periodic table. I'm just zooming in on it here so that way I can write on it and all that kind of stuff. All right, so what we're going to do is let's take a look at the bits of information. The first two that should really stick out to you are the name. We've got sodium here, and we've also got the symbol for sodium. And you'll notice that it does not necessarily match up. You're not going to have like an S and an O for sodium or an SD or whatever. Sometimes if they are using different roots, Latin, Greek, the symbol and the actual name may not necessarily match up as you would expect, but you can always expect that the symbol will begin with a capital letter. And if there are two letters that are attached to this particular symbol, for example, N and A, the N will be capitalized, but the second letter will always have to be in lowercase. That becomes really important when we start putting these guys together to form compounds and stuff like that. All right, what does this box tell us? Well, first of all, let's take a look at the name here. So we've got sodium. And this is just simply, the element name here. This is sodium, and it's just the name of the element. After that, we've got the symbol here, and you'll notice that this symbol is, like we said before, starting with a capital letter and then ending off with lowercase if there is a second letter after it. This is just our straight up symbol for that particular element. Straightforward, pretty easy. All right, let's go back to this. We're looking at the number 11 here. And what does this number 11 mean? This number 11 is important because it is going to tell us, well, this number is what we'll call this number first. We call this number the atomic number. The atomic number. Sorry, I'm having to scroll a little bit here so I can try to fit all this writing in here. You won't notice it, but I'm having to adjust my screen a little bit here. And even with that, my writing looks awful, so I apologize. But that's the atomic number. What does the atomic number tell us? The atomic number will tell us the number of protons that are around this particular element. All right, so sodium, when it comes to sodium, sodium has 11 protons in its atom, and you would actually find these protons in the nucleus of this atom. So if we start going back, and let's sort of bring this table back here. If we start looking at this table, you'll notice that every element has its own atomic number. We have lithium that has 3. Atomic number of 3. We have magnesium that has an atomic number of 12. So you can start to see that every element has its own atomic number, and that atomic number tells us the number of protons. It's very important because if we start changing the number of protons, if by some chance I had the ability, I had the ability and the technology to change the number of protons within this particular element here. So if I could take this 11 and turn it to a 12, this would no longer be sodium. It would be the next element on the periodic table. It would become magnesium. So that's why it's so important. 11, this number here for sodium is the atomic number of sodium. And again, it tells us the number of protons. All right. that brings us then to this number here. What does this number, 22.99? This is the atomic mass of this particular element, or the atom that makes up this particular element. And let me just draw this out. Atomic mass. Atomic mass. Now, what makes up the atomic mass? Well, if we take a look at what makes up the atom, and I'm going to draw this really bad looking model of the atom here. We're going to say that in the middle of any atom, you're going to have stuff like, protons, and I'm going to draw just a simple helium, I guess. Neutrons, so protons are the blue, neutrons are the red, and let's draw these dots here as being the electrons that are flying around the outside. That's a pretty poor looking atom, but you get the idea. And this isn't representing sodium, unfortunately. This is just representing just a helium, but we're just using this as an example of an atom. What we're going to find is that in the middle of our atom, you're going to find stuff like the proton. Protons are going to be found in here. This is where the proton is. And you're also going to find neutrons. And on the outside, like we said, these are the electrons there. I'm going to put that with an E. All right. So getting back to the topic of, well, what is our atomic mass? It's the mass of the atom that we're looking at. And if we start to take a look at what's inside the atom, we can see that it's made up of protons, neutrons, and electrons, these three guys right here. When we start looking at how much these guys weigh relative to each other, we can say that the bulk of the weight of an atom really comes from the protons and the neutrons. The electrons are so small in comparison to the protons and neutrons that we can consider their mass to be almost negligible when you compare it to the protons and the neutrons. And we will often assign a mass weight or a mass of 1 to each proton and roughly a mass of 1 to a neutron, an atomic mass. So when we add these together, if we say that every proton weighs 1, every neutron weighs 1, for this particular element that we're seeing here, or this atom here, we can say that this element has 2 protons and 2 neutrons. And as a result, its atomic mass is probably going to be around 4, simply because we've got 2 protons, 2 neutrons, and yes, we do have 2 electrons down here, but we said that that weight is pretty much, or that mass is going to be pretty much negligible when we start just considering it in comparison to the protons and neutrons. So that's where the bulk of the mass of the atomic mass is coming from, is from the protons and neutrons. So let's go back to what we were looking at over here, which is the atomic mass of sodium. If sodium has an atomic mass of 22.99, we can say basically that that mass represents, for the most part, the mass of the protons and the neutrons. One important thing to note is you might be asked, and when you start doing stuff like board diagrams, you will need to do this, is you will need to take this atomic mass and convert it to what we call a mass number. And what this is we're basically going to round it off to the nearest unit. We're going to get rid of this sort of decimal behind it, and we want to make it either a 22 or a 23. And again, this just involves rounding up. So because this is a 22.990, it is far closer to a 23 than it is to a 22. And when we start talking about converting this into a mass number, the mass number for sodium, let me just draw this out here, mass number for sodium is going to be 23. And there is a reason why we're doing this, and this is going to bring us into board diagrams, which will be the next video. But this is what you should be able to do with any element in the periodic table. And again, we're going to be focusing in on sort of the the first maybe 20, 25 elements, but technically speaking, you should be able to do this for any element. And when you look at any one of those elements in the periodic table, just be aware. Can you tell me the name? Can you tell me the symbol? Can you figure out how many protons an element has, and how many and the atomic mass of that particular element or that atom of that element, as well as its mass number? And what do we mean when we say it has an atomic mass of 22.99? Where does that mass come from? All right, so that's pretty much it. That's how you're going to have to be able to navigate the periodic table and what you're going to be expected to do when you're asked to take a look at the information on that table. All right, good luck.